Good day, students. Today we're going to keep on topic 2, but the section that we're going to be dealing with now is something called simultaneous equations. Now guys, you would have come across equations where you have to solve for an unknown variable. The reason why we are doing simultaneous equations at this stage is that we are going to be using it when we are dealing with arithmetic progressions. Simultaneous equations. First and foremost, a linear equation is an equation that consists of a left-hand side and a right-hand side separated by an equal to sign. Two equations can be described as simultaneous if they are satisfied by the same values for the unknowns. In the case of level 2, we will be dealing with two equations, and in the two equations the question will read to solve for x and to solve for y. Both equations must have the same x value, and when we calculate the y values will satisfy both equations. At level 2, however, both equations that we will be dealing with must be linear. At level 3, you will come across a more difficult simultaneous equation. At level 2, there are three basic methods to solve simultaneous equations. We have something called the elimination method, we have the substitution method, and by the way, for this session we'll only be dealing with the elimination method. The last method is called the ATA method. This is a new method, but it will be done on the next video. Worked examples. The question in your examinations will read, solve for the unknown variables. In this case, I need to solve for A and I need to solve for D. Automatically, you see, because I have to solve for A and D, I am given two separate equations. Now you might be wondering, why A and why D, not X and Y? You will see, guys, this will become more meaningful when you do arithmetic progressions. But for now, we're solving for A and D. The first step will be to label the equations. I like to call the first equation equation number 1. The brackets with the 1 inside means equation number 1. A plus 7d is equal to 15 becomes equation number 2. Now the method that I'm employing here is called the elimination method. Eliminate means to get rid of something, to eliminate it. In this question, I am going to try to eliminate one of the variables. For me to eliminate one of the variables need to be the same, irrespective of the sign in front of them. So for example, if I have 5a and 5a, the mere fact that a with its coefficient are exactly the same, it means I can get rid of them. I simply subtract the two. Alternatively, if one is negative, for me to get rid of the a, I simply add the 2. In this question, this is an a, that is an a, the coefficient is 1, which means they are the same. If they are the same, it means that I can eliminate. And how do I eliminate the variable a? I simply take equation number 2, I subtract equation number 1. Now watch the subtraction, guys. I'm taking equation number 2, subtract equation number 1. Equation number 2, subtract equation number 1. Equation number 2, subtract equation number 1. Here I am left with a minus a, which is basically 0. What about 7d minus 4d? And 7d minus 4d is equal to 3d. I bring down my equal to sign. If I'm subtracting the two equations, it becomes 15 minus 9, and 15 minus 9 is equal to 6. And now, guys, it becomes easy because d is equal to 6 divided by 3, which is equal to 2. I have only solved for one variable. I still need to go solve for the second variable, which is a. And this follows a simple mathematical process. All I do is I substitute the value for the variable which I've calculated previously. In this case, d is equal to 2. I substitute d is equal to 2 in any equation. For convenience, I'm going to substitute it in equation number 1, which means a plus 4 times d. And what is the value for d now, guys? The value for d is equal to 2, and this is equal to 9. And all I do now is a plus 8 is equal to 9, and a is equal to 9 minus 8, which is equal to 1. And this is my simultaneous equation solved. Quite easy. Let's go over to another example. In this case, I have example number 2. Now I brought in my x's and y's. Solve for x and solve for y. My first step would be to label the equations. The first equation, call it equation number 1. The second equation, call it equation number 2. Elimination means I need to eliminate a variable that is the same. If I look at the x's and the y's, there's nothing the same. This is 4x, there's a 2x. This is 3y, there's a 4y. I have a problem. But this is an equation. I need to manipulate one of the equations so that either the x's are the same or the y's are the same. In this case, I take equation number 2 and I multiply equation number 2 by 2, which means I multiply the left hand side by 2, I multiply the right hand side by 2. I did not change the equation. If I multiply the left hand side by 2, 2x times 2 is 4x, minus 4y times 2 is minus 8y, is equal to minus 8 times 2 is minus 16. I now have created another equation which I call equation number 3. But basically it's equation number 2 just revamped, becomes equation number 3, which means I don't worry about that equation anymore. I simply consider 1 and 3. If I look at equation 1 and if I look at equation number 3, I immediately see there's a 4x, there's a 4x. Both are positive. By either adding or subtracting, how can I get rid of the 4x? Correct. I subtract. I simply take equation number 3 minus equation number 1. Now guys, I'm going to do this at the side here so you can see exactly what I'm talking about. I have 4x minus 8y is equal to minus 16. The next equation I have is 4x plus 3y is equal to 17. And what did I say I want to do? I want to subtract the two equations. And when you subtract, you know how it works. I simply change the signs at the bottom. That becomes negative, that becomes negative, and that becomes a negative. Yes, 4x minus 4x falls away. Minus 8y minus 3y is negative 11y is equal to, and minus 16 minus 17 is minus 33. But you can simply work it out from here, guys. Minus 11y is equal to negative 33. And I simply solve for y. Y is equal to, divide this side by minus 11, divide that side by minus 11, I get y is equal to 3. And of course, I need to solve for x. And like I mentioned before, substitute y is equal to 3 in any equation. Again, for convenience, I choose equation number 1. Now in equation number 1, I know the value for y. I need to get the value for x. And it goes and says 4x plus 3 into, what's the value for y? 3 is equal to 17. 3 times 3, guys, is 9. Take it across. 17 minus 9 is equal to 8. 4x is equal to 8, which means x is equal to 2. Let's move over now to our last example. Example number 3. In example number 3, a slightly more difficult. This, guys, you should expect in your examinations as well. To solve it, firstly, let us label our equations. That's equation number 1. This becomes equation number 2. What do I notice, guys? I've got a 7x, a 5x, 6y minus 8y. It becomes difficult to take one of the equations by multiplying it to anything to get the second equation, which means when you come across an example like that, you would have to manipulate both equations. Firstly, what happens if I take equation number 1 and multiply it by 8? You could multiply it by 7 and multiply this by 5 and multiply this by 7. Yes, but let's multiply it by 8. If I multiply this by 8, it means 7x times 8, 6y times 8, 71 times 8. And that gives me 56x plus 48y is equal to 568. I'll call this equation number 3. Let's take equation number 2 now, but multiply equation number 2 by 6. And this becomes easy, guys. Look at the numbers, 6 and 8. I multiply that one by 8. I multiply this one by 6. And if I multiply 5x times 6 minus 8y times 6 is equal to minus 23 times 6, I get 30x minus 48y, which is equal to minus 23 times 6, which is minus 138. And now I call this equation number 4. Immediately, you see I have a positive 48y and I have a negative 48y, which means I have a 48y, 48y. I can get rid of the y's. And how do I get rid of the y's now? I don't have to all the time subtract. In this case, I simply add my two equations. Plus 48 minus 48, which is equal to 0y. So it becomes equation number 3 plus equation number 4. Watch this, guys. 56x plus 30x is equal to 86x is equal to 568 plus minus 138 is 430. Use your calculators if you are unsure. To solve for x, I divide the left hand side by 86. I divide the right hand side by 86. X is equal to 5. And again, substitute x is equal to 5. You can put equation 1, equation 2, equation 3, equation 4. It doesn't make a difference. I'll use equation number 1. 7 multiplied by, what's the value for x? Yes, it's 5. Where did I get the 5? I have already calculated it. Plus 6 times y is equal to 71. 7 times 5 is 30. Correct. 6y is equal to 71 minus 30. 35. 7 times 5 is 35, which is equal to 36. And y is equal to, divide by 6, divide by 6. Y is equal to 6. Now, guys, we went through this quite fast, but I'm sure you would be able to get the hang of it once you try a few examples. Activity 1. Solve for the unknown variables. You only have 5 examples. Please copy them down. And now we can move to the solutions. For this, guys, I'm just going to give you the answers dependent on the method that you want to use. Some of you might want to try the ATA method, which you can view in the next video. Once you do that, verify that you get the same answers using activity number 1. And these are the answers. Thank you very much, ladies and gentlemen. Just remember, look at the ATA method. It is again a very, very simple and interesting method. I thank you once again. Goodbye and good luck with your studies.